Hi, Anthony Carruthers, Better Lesson, Master Teacher Project, and here we are at the moment of truth. We've just finished deriving the equation of a parabola with focus -4, 7 and directrix y equals 3. Now we're going to use Geometry Sketchpad to see if the equation that we derived is actually the correct equation. So in Sketchpad, I'm going to graph that function that we derived. And that function was 1/8 times the quantity of x plus 4 squared plus 5. Okay, so Sketchpad is going to graph that function for us. Okay, and there it is. And now I want to see if this actually fits the definition of parabola that we've learned. So for that, I'm going to graph the directrix and also the focus. So within Sketchpad, I want to make sure I'm on snap points, and I am. Okay, I'm going to grab a point and put one at -4, 7. So let's see, -4 right about there, 7 right about there. And I also want to graph the directrix. So for that, I'm going to get the line tool. And we want y equals 3. So I'm just going to pick any point that has a y coordinate of 3. And then another point that has a y coordinate of 3. Okay, so that's the line y equals 3. Okay, I'm also now going to need an arbitrary point that's on the parabola. So we'll put that point there. And just to keep it consistent with what we've done in the lesson, let's call that P. And this point here, which is the focus, to keep it consistent, again, we'll call that F. And I also need to find the point that's directly below P on the directrix. So for that, I'm going to select P. I'm going to select the directrix. And I want a line that's perpendicular to the directrix passing through P. So for that, I'm going to construct a perpendicular line. And just so I have that distance from the point to the directrix, I'm going to construct that segment. And then I can clean up the excess. So I'm going to hide that perpendicular line. Okay, so what we know ought to be true, and let me do some labeling before we talk about that. This, to keep it consistent again, should be A. So what we know ought to be true is that the distance from P to A ought to be the same as the distance from P to F. So I'm going to also draw that segment from P to F. And then what I'll do is measure those segments. And if I were demonstrating this for students, I'd ask them, like, what should happen? How can we make sure that this thing is doing what it's supposed to do? And they would be kind of guiding me through the steps on this Sketchpad demonstration. So in any case, I'm going to measure the lengths. And we see that PA and PF are both 10.9 centimeters. And we want to make sure that we didn't just have some extreme luck and just happen to get them both the same. So we want to vary the location of P. And we'll notice that no matter where P is on the parabola, that distance from the point to the focus and the point to the directrix is always the same. And from that, we should be pretty convinced that the equation that we found is the correct equation. So this is how we verify that our equation we derived is correct. I'm Anthony Carruthers, Better Lesson, Master Teacher Project.